Today we'll be talking about binomial probability. So here is the formula we're going to be applying, and today we're going to talk about what exactly is happening. So this n choose r right here, recall that notation simply means n choose r, or the combination function. This p right here, that's going to be your success rate. This 1 minus p, that's going to be your fail rate. This r is going to be your number of successes, and this n minus r is going to be your number of failures. Now, I don't want you to worry about memorizing this formula because it's pretty abstract. So we're going to talk about kind of how this works in an example right here. It says we roll a fair die 4 times. Find the probability that we roll all threes, no threes, exactly 2 threes. So to show this, we're going to talk about why this is a binomial probability question. And there are a couple conditions that have to be satisfied. The first condition is that you need a success-fail structure, meaning only 2 outcomes are possible. You have a success and a fail. So in example 9, we can see for letter A, the success would be getting a 3. And if it's a fair die, that means you have a 1 in 6 chance of getting a 3, which means your failure rate is the other 5/6. Notice how these both will add to 1. So that has to happen. That's your first condition. The second condition is that your trials are independent. So independent meaning that the second trial has no effect on the first, and the third has no effect on the second, and so on. Each individual trial is going to be independent, meaning they're separate from each other. So there's no effect between trials. So for example, drawing cards would not fit in this category because once you draw a card, the next card is affected by what you've already drawn. But rolling dice is a great example. Okay, so let's try it. All threes. So according to this formula, it says your success rate, which is 1/6, so I'm going to write that down. You want your success to happen, and it says rolling it 4 times. You want all of them to be your success. So you can write 1/6 to the 4th power. Now, this is the weird part. You see this right here? This is super important because what that's going to do is it counts the ways it can happen. So for this particular example, it's kind of useless because when I put in 4C4, this is just 1, which makes sense because there's only one way you get all threes. You would get 3, 3, 3, 3, and that's the only way that this event could happen. So we know that's going to be 1, but we can still plug in our calculator to figure it out. So 4C4 multiplied by 1/6 to the 4th power. Let's make it a fraction. Okay, 1/1296. So for this section, as much as possible, use fractions. It'll make it a cleaner answer. Next one, no threes. So this is very similar to the last question, except we want to know threes. So in this case, our success would be 5/6 because that's what we want to achieve this. And our fail rate will be 1/6, meaning you do get a 3. And notice how it's very, very similar. We want 5/6. That should happen 4 times. And then you have your 4 choose 4. Now you type that in your calculator, and you're going to get 625/1296. Exactly 2 threes. So now we go back to the other success fail structure. So we want a 3, meaning your success is 1/6. and your fail rate is going to be 5/6. Now in this problem, we are going to see the choose function work here because we want to succeed twice. So 1/6 squared, that means we're going to fail twice. And if you just do this, again, this is not going to account for the ways it could happen, meaning I'll put that on the side here, ways it can happen, because it could be success, success, fail, fail, or fail, success, success, fail. It could be fail, fail, success, success. So in order to account for all of these situations, we have to put the choose function, and we're going to put for choose 2. For, because that's your total trials, and we're picking 2 successes. So notice how this now is meaningful, whereas in other ones it didn't really do much, but in this problem it's definitely meaningful. So you're going to type that into your calculator, and you're going to get 25/216. Okay, let's try another example. So it says, suppose Michael makes 90% of his free throws if he shoots 20 free throws, and his chance of making each one is independent. So again, this is the assumption we're making, and I'll make that for all these sports questions as well. What is the probability that he makes all 20? So clearly our success rate is going to be 90%, so I'll put 0.9. Our fail rate is going to be 0.1. If you want to make all 20 free throws, that's going to be 9 out of 10 to the 20th power, and then 20 choose 20. So you print your calculator, and you're going to get, this is approximately 12.2%. So for this one, when I show you the calculator, notice how when you put 9/10 to the 20th power, you get this. So this clearly, we could put this fraction, but because you're dealing with sports, we're going to actually just put the rounded percentage. So 12.2 is going to be fine here. Okay, 18. So exactly 18 makes, so we're going to put 9 out of 10, or 9/10, 18 times. That means you fail 2 times. And at the front, we're going to put 20 choose 18. Note that you could also make this 2, and you get the exact same answer, because 20 choose 2 and 20 choose 18 would create the exact same number. So whatever your preference is, you can put that here. And then you put that in your calculator, and you're going to get about 28.5%. Now here's a tricky one. It says at least 18. So at least 18 means there's a couple cases that could happen. There's a chance that you make 18. So the probability of making 18 plus 19 or plus 20. So we should figure out each of these individually, and then we'll just add them. So 18, we already have that from earlier. That's about 28.5%. So let's use that number. 19, we don't have that, so we'll calculate that. That's going to be 20 choose 19 multiplied by 9/10 to the 19th, 1/10 to the 1. Plug that in, you get about 27%. And the last one, we did that at the very beginning. That's just 12.2. So add those all together, and you get about 67.7%. So that'll be your chance of making at least 18, given these statistics. Okay, let's go to our final example. Class of 30 studies 1 foreign language and 1 science. The students' choices are shown in the table below. So here is a table of everybody in a whole bunch of classes here. So for example, in French, that means there are 11 people total taking French. Of those 11, 1 is in chemistry, 3 are in physics, and 7 are in biology. And you follow that logic for the whole thing. So for example, if I'm looking at this 9, that means 9 are in physics total. And of those 9, 4 take German, 2 are in Spanish, and 3 are in French. So now let's answer some questions. A, what is the chance that the student studies chemistry? So for A, let's really take a look at the chemistry people. So that's going to be right here. So there are 10 total people in chemistry, and that's out of the whole total right here. So the answer should be 10 out of 30, which is 1/3. B, the student studies Spanish. So again, let's look at Spanish. That's going to be right here, 9, and that's out of 30, which is your total. So nothing really crazy so far. It's pretty easy. But now it says the student studies chemistry given, that's important, that the student studies Spanish. Or if you've taken stats, this, the probability of C given S. So that vertical line means given. A question like this is called conditional probability. So to do this question, what you want to do is really look at what it's saying. The student studies chemistry given that the student studies Spanish. So we're looking for the chance that they study chemistry given that they're already in Spanish. So focus on this whole row right here. This is everybody in Spanish, which means your denominator is 9 because you're only going to consider people in Spanish. And of those 9, how many are in chemistry? 5. And that's your answer. Now the other way to do it is this, and a little more technical. You can find the probability that they're in chemistry and Spanish and basically divide out the probability of Spanish. So for example, the chance of C and S happening, so this would be chemistry and Spanish right here. That's how many people are in total. So that's 5 out of 30. And then divide it by the chance that they're in Spanish. And the chance that they're in Spanish would be right here, 9 out of 30. 30s cancel out, and notice how you get the exact same number. But conceptually, I would recommend think of it like the first way I showed you. This is more formulaic, and this is just the math behind what we're doing. The easiest way is to just think, given that they're in Spanish, so look at everybody in the Spanish realm right here, how many are also studying chemistry? And that's 5 out of 9.